Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.26. While solving this problem, we will be using Kirchoff's voltage law. This law states that sum of supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. According to this law, a cumulative supplied and dropped voltage in a closed loop is always 0. Now move towards the problem. Exercise problem number 2.26. Find voltage VAE and VCF in given below figure. This is the circuit diagram of given problem. We have to find voltage between these 2 points AE and these 2 points CF. If we observe, the only information that is provided is in the form of voltage, and it is asked to calculate the value of voltage as well. No other parameter is specified, so we will use Kirchoff's voltage law to solve this problem that is purely based on voltage. Before starting the solution of this problem, we have to identify the direction of current inside this circuit. I am assuming the direction of current clockwise. You may take it counterclockwise as well. It totally depends upon your own choice. Now we are interested to calculate voltage between these 2 points A and E, labeled as VAE, which is indicating that A would be on higher potential than point E, and between these 2 points labeled as VCF, which is also indicating that point C would be on higher potential than point F. Now first we will calculate voltage VAE. For that purpose we will apply Kirchoff's voltage law for this semi-closed loop. We will start from here. Current entering terminal is positive because current direction is clockwise. So voltage across this voltage source will be taken with positive sign, plus 12 volt. Move to next element. Voltage across this resistive element will be taken with minus sign because current entering terminal is negative. Now at the end, voltage between these 2 points VAE will be taken with positive sign because current entering terminal is positive. KVL equation for this semi-closed loop is provided here. Plus 12 volt minus 6 volt plus VAE is equal to 0. Inside this equation, we only have one variable VAE and we are interested to calculate its value. So we will subtract 6 from 12. The equation will become 6 volt plus VAE equal to 0. Now place this 6 volt on the other hand side of equal to calculate the value of VAE, that will become minus 6 volt. Now we will try to find voltage VCF between these 2 points. For that purpose, we will apply Kirchoff's voltage law inside this semi-closed circuit. We will start from here. Current entering terminal is negative due to clockwise direction of current. So voltage across this resistive element will be taken with minus sign, minus 6 volt. Move to next resistive element. Current entering terminal is negative, so voltage across this resistive element will be taken with minus sign. Move to next element. Voltage across this voltage source will be taken with positive sign because current entering terminal is positive, positive 9 volt. At the end, voltage VCF will be taken with positive sign because current entering terminal is positive. Now inside this equation we only have one variable VCF and we are interested to calculate its value. Solve this equation. Add 9 volt, minus 4 volt and minus 6 volt together. The answer will be minus 1 volt. Now place this minus 1 volt on the other hand side of equal to calculate the value of VCF, that will become 1 volt. So voltage VAE inside this circuit is minus 6 volt and VCF is 1 volt. This was exercise problem number 2.26. Thank you. See you again in next video.